Hello everyone, I hope that you are all fine and safe. So in this lecture or in this video we're gonna discuss how to make the velocity analysis for disk or for disks. Okay, so let's take an example. For example, here we have your own car. For example, this car, when you push the pedal, the car moves forward, right? Why does the car moves forward? Because the tire is rolling. The tire is rolling. What is the meaning of rolling? Rolling is a combination of rotation and translation, which means the tire itself is rotating and the car is moving forward, so it's translating. The combination of rotation and translation in motion is called rolling. Okay, that's easy. Now let's go to the next case. You took your car and you went to the mechanic shop, okay, to fix your car, and the mechanic put your car on the hydraulic jack, so he elevated your car from the ground. So in the first case your car was on the ground, the second case your car is not on the ground, is elevated on the ground. So let's just assume you are inside your car and you push the pedal as well. So the tire will rotate as well. But does the car moves forward or not? Of course not. The car will not move forward. Why? Because the car is elevating using the hydraulic jack, because there is no ground, there is no friction. Let's go back here. The car was moving forward due to the ground, due to the friction. So the tire was rolling due to the friction. Without the friction, the car will not move forward. It will make only rotation. So it will rotate only. So what made the difference here between the first case and the second case? Both of them were the same car and both of them the tire was rotating. But the first case there was translation, and in the second case there was no translation, which means you can have rolling or translation when you have a friction. When you have this point, you can find your car moving forward. Therefore, this point is called the instantaneous center of rotation. So the rolling for us is not the translation, is not rotation about fixed axis. It's like the third case, the general motion. Therefore, the disk always rotate around the point of contact with the ground. The disk always rotates around the contact point with the ground. Okay. So let's apply on this idea in the next problem. So we have this problem. We have the AB. The length of AB is 0.4, the length of BC is 1 meter, the angle of AB is 30, and the angle of BC is phi. It's unknown for us. The radius for the disk is 0.2, and the disk is rolling on the ground. Okay, find the omega disk. So what shall we do? First of all, let's find the phi. So the phi is in triangle. EBC, and let's apply the sine rule, and it will be as follows: 0.4 over sine phi equals to 1 meter over sine 30. Therefore phi equals to 1154. That's the phi. Okay, next we're gonna start analyzing the first member, the member with the givens. the member AB, because the omega AB is given in it equals to 15 radian per second anti-clockwise or counterclockwise. So let's start analyzing the first member AB and its rotation about fixed axis. Right? Yep. So let's draw it first. And the omega was counterclockwise, therefore the velocity will be in this direction. This is the velocity of B, and this angle was 30, therefore this angle will be 60. VB equals omega AB times the length of AB. Therefore we can say that VB equals omega AB times AB. Omega AB equals 2. 15 times AB. AB was 0.4. Therefore VB equals 26 meter per second over 60-degree angle. Let's go to the next member, the member BC. The member BC is not rotating around fixed axis and it's not translating, therefore you can say that the member BC is moving general motion. So to find the I in the member BC, you have to know the direction of VB, which is already known, and you have to know the VC, which is unknown. So you have first to go to the member C, the disk, to find the velocity VC, and then go back to the member BC. Let's go to the disk. So the disk, here it is. And we remember that the whole idea in the disk, it rotates instantaneously around the contact point with the ground. So we can call this point I1, and the point C was in the middle. And let's go back. If the AB will rotate counterclockwise, therefore the B will move to the left, the disk C will move to the left or will move to the right. When the AB rotates counterclockwise, so it will goes to the left. So it is already known that the omega of the disk will be in this direction. This is the omega of the disk, and to find the velocity VC, we connect the C with the point that it will rotate around, and we make perpendicular in the same direction of the omega, and this is VC, and VC will be equals to the unknown omega disk multiplying the IC. Let's go back to the last member BC. And it was moving generally. We will start by drawing the member BC. This is the B, this is the C. The VC is already known, it's to the left, and the VB was over 60 degree. The VB was over 60 degree. This was the VB. How to get the I point? We'll make perpendicular, and we'll make perpendicular over the two velocities. They will meet here. This is gonna be I2. This is the instantaneous center 2 for the member BC. Therefore the omega will be in this direction. This omega will be the omega BC. Okay, great. And we need to find the I2B, and we need to find the length of I2C. How to get this? We can get it by the following, by doing the sine rule. But to find the sine rule, we need to find some angle. So this angle was phi, which was 1154. Therefore the remaining will be 90 minus 1154, so it will be 78.46. Let's remember that this was the A and this was 30 degree, so this angle will be 60, right? So now we can get this angle. It will be psi will be equal to 180 minus 60 minus 78.46. So psi will be equals to 41.54 degree. This is psi. So let's go and make the sine rule in the triangle I2BC between two quotes. This is the sine rule. So we can say that the I2B over sine 78.46 equals to I2C over sine 41.54 equals to BC over sine 60, and the BC was 1 meter. Therefore we can find that the I2C equals to, and the I2B equals to, the I2C was 0.766 meter, and the I2B will be 1.131 meter. This is the I2B and this is the I2C. Great. So now we can get the omega. So the VB equals to omega. The VB will be equals to omega BC times the length I2B. VB equals omega BC times I2B, and the VB is unknown and the I2B is unknown. Therefore we can say that the omega BC equals to VB over I2B, with the VB was 6 meter per second and the I2B was 1.131. Therefore we can say that the omega BC equals to 5.305 radian per second, and it was rotating clockwise. This is the omega BC. Now we can find the VC. VC will be equals to omega BC times I2C. The omega BC is 5.305 times I2C, which was 0.766. Therefore we can say that the VC equals to 4.064 meter per second, and the direction of the VC is already known, it's to the left. So let's remember that the required from this problem was to find the omega disk. Okay, and we already know the VC, and the VC equals to omega disk then multiplying the IC. So we can say from another color, from disk, the VC equals to omega disk multiplying I1C. Therefore the omega disk equals to the VC over the I1C. The VC was 4.064 and the I1C was 0.2. Therefore we can say that the omega disk equals to 20.32 radian per second, and the direction of it was counterclockwise. I hope that this was clear enough, and let's meet you in the next video, in the next subject, which will be the acceleration analysis. Good luck, see you next time.